In the previous videos, our function was linear, but now we're moving on to a function that is quadratic. And remember, this is quadratic because it is degree 2, which just means that the largest exponent is a 2. So before we move on to a more complicated function like this, let's first just practice our algebra skills. So we're not going to compute the entire difference quotient here. We're just going to find and simplify the f of x plus h part. That's just the first part of the difference quotient. So f of x plus h means we're going to take x plus h, whatever's in the parenthesis, and we're going to input it into our function in place of x. So f of x plus h will equal, instead of x squared, we're going to input x plus h for x, minus 3 times, and instead of x, again, we're going to input x plus h. Really important that you remember to put the x plus h in place of every single x in the function, and then plus 4. The rest here we're going to simplify. Just do it very carefully so we're not making any silly algebra mistakes, especially right here. X plus h, the quantity squared, means we have to multiply it by itself. Then we're going to distribute negative 3x minus 3h plus 4. Then multiply x plus h times x plus h. So that'll be x squared plus xh plus xh plus h squared minus 3x minus 3h plus 4. And then finally combine like terms. So we'll have x squared plus 2xh plus h squared minus 3x minus 3h plus 4. Not a lot of simplifying in this case. Let's try that process again for a different function. This function is still quadratic. So when we go to compute that f of x plus h, again, what's in the parenthesis is your input. So x plus h is the input. I'm putting that into the function in place of x. So f of x plus h for this function will be 3 times the quantity squared. And again, we're going to input x plus h in place of x, minus 5 times our new input, which is x plus h, plus 2. Sometimes in the beginning, I think the color coding does help so you can really clearly see what you're substituting into the function. Now here, be careful with the order of operations. Make sure you don't distribute that 3 first, but rather that you deal with the exponent first. We always do exponents before multiplication with order of operations. So then we're going to distribute the minus 5. And then here, because we do have 3 times x plus h times x plus h, you can multiply in any order. I'm going to choose to go ahead and multiply the x plus h times x plus h first. So that's going to be x squared. We'll actually get xh plus xh. I'm going to go ahead and add like terms here and do that in one step. And then I'll distribute the 3. So 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 2 for this one. That would be my simplified f of x plus h portion. So now let's take a quadratic function and do the entire difference quotient. So remember, what I've done here is just the first portion of the difference quotient, just the f of x plus h part. Now let's see if we can put everything together. Now let's compute and simplify the entire difference quotient for the function f of x is equal to x squared minus 3x plus 4. So the difference quotient is f of x plus h minus f of x all divided by h. And the first portion of the difference quotient is the f of x plus h part. And that's what we did in our previous example. However, I'm going to go ahead and demonstrate how to find that again, just so that you can see everything put together in one problem. So f of x plus h means we're taking the x plus h, we're inputting it into the function everywhere we have an x. So instead of x squared, it becomes x plus h, the quantity squared, minus 3 times our new input, x plus h, and then plus 4. Then we're going to subtract, and we are subtracting f of x. Now you can think of f of x as a function where we're going to input x, I suppose, if you wanted to. If you see the x there, you're thinking, oh, I'm going to put in x. Or you can just realize that f of x is actually the original function, which was x squared minus 3x plus 4. But be careful here, we cannot leave it in this form because we have to recognize that our function has 3 terms, so we need to be sure we're subtracting the entire function. So we need parentheses there for this to be accurate, so we show we're subtracting everything. And now we're just going to go ahead and clean this up with a bit of algebra. So multiplying x plus h times x plus h, distributing your minus 3, and just being really careful here that you're not making any careless mistakes with any of the signs, with the distributing or the multiplication. X plus h times x plus h will be x squared plus 2xh plus h squared minus 3x minus 3h plus 4. That you'll notice was the same quantity we had on the previous example. Now we just have the rest of the difference quotient with it. Now let's see what subtracts out. It looks like we have x squared minus x squared that will subtract out, and a positive 4 minus 4, which will equal 0. We also have a negative 3x and a positive 3x. So it looks like what remains is a positive 2xh plus h squared, and then a minus 3h. So positive 2xh plus h squared minus 3h, all divided by h. Now notice in the numerator, there's 3 terms, but there is a greatest common factor. We can factor out an h. So if you factor out an h, you're left with 2x plus h minus 3, all divided by h. And by factoring out the h, now we have multiplication here in the numerator, so we can go ahead and divide out our h's, which is going to leave us with an answer of 2x plus h minus 3. And that's going to be our answer for the difference quotient for this particular function. And again, later on in the study of calculus, you're going to have a better, clearer understanding that if we knew an x value and if we knew an h value, then this quantity would really represent the slope of a secant line. So if you can imagine, the original curve f of x was a parabola. It was a parabola that opens up. So if we chose a specific x value and then we knew an h value, then that would allow us to draw a secant line that cuts through the curve, and the slope of the secant line would be found, or could be found, using the difference quotient, this 2x plus h minus 3.